So within a circle, you can also inscribe a quadrilateral. So inscribe just means you put it inside. So if you have a circle, you can just draw 4 lines to make a quadrilateral inside that circle. So there's one thing that's pretty interesting about this, though. Whenever you inscribe a quadrilateral, and it'll make sense when we walk through it here, the opposite angles will be supplementary. So the angles that are across from each other are going to add to 180. Now let's kind of dig into that for a second. Angles that are across from each other. So these angles that are on those vertices. The whole circle adds up to 360 degrees. So if this angle was, what does that look like? About 120 degrees or something? Just estimate. That is an inscribed angle, which means the angle is half the arc that's formed by its 2 sides. So that means this whole arc over here will be double 120, which would be 240. Which means the rest of the circle, if we go this way, I'll outline it in green, the rest of the circle will be whatever's left over from 360. So if that was 240, we'd have 120 left over for this arc, the whole thing. And then the opposite side of that quadrilateral is an inscribed angle that cuts that. So it's going to be half of 120, which would be 60. So you can see the way it works out, they have to be supplementary because each angle is going to be half of its portion of 360. So together they're going to be half of 180, or half of 360, which is 180. So the inscribed angles, or the angles of an inscribed quadrilateral, opposite angles will be supplementary. So if angle P is 57 degrees, PQRS. So if P is 57, then R is the one that's across from it. So we can figure out R because it'll be 180 minus 57. They have to be supplementary. But the only thing we know about Q and S is that they're going to add to be 180. We don't know what either of those are. All we know is that Q and S will add to 180. We just don't know what they are. So here we have some inscribed quadrilaterals. So we can find the angle measures. We can find all the angle measures because we know these angles that are across from each other, P and R, will add to equal 180. So 15y plus 17 plus 5y plus 3, they add to equal 180. So we got an equation, we can solve for y. Oops, didn't add correctly. 20y equals 160. So that means y equals 8. So if y is 8, then this angle right here at angle P 5 times 8 plus 3, 43. This angle up here at Q, 8 squared, 64, plus 53. That is 117. This angle over here at R, remember y is 8, so 15 times 8, 120, plus 17, 137. Also remember that 43 and 137 has to add to be 180. And they do. So we can use the fact that they are supplementary to find angle S. We have the angle across from it was 117, so subtract that from 180 and we figure out what angle S is. 180 minus 117, 63. You can do the same thing with this example. We can solve for x and then plug it in to figure out what all the sides are, what all the angles are. So the two angles that are across from each other, J and L, I think that's how it's where it's supposed to be though. They are supplementary, so 39 plus 7x plus the angle across from it, 6x minus 15 equals 180. So 13x, 39 minus 15 is 24. We get x equals 12. If x is 12, we can plug that in to find all 3 of the angles that have x involved and then find the 4th one. So plug in 12. I'll start down here. Measure of angle L. 6 times 12 minus 15. 6 times 12, that's 72. Minus 15, 57 degrees. Which means the angle across from it has to be supplementary. So you could plug in 12, or you could just know that since this one's 57, the other one has to be 180 minus 57. So 180 minus 57 is 123. Then you can plug in 12 over here to find the measure of angle K. 12 times 20 divided by 3. That's 80. Which means the measure of angle M is 100 because those two angles have to add to be 180. Exact same process here. Angles that are opposite are going to add to be 180. So 12z minus 27 plus 37 plus 5z equals 180. Combine my terms there, we get 17z plus 10 equals 180. Subtract the 10, you get 170, so Z equals 10. So that means the measure of angle U will be 120 minus 27, which is 93. The measure of angle W is across from that, so they have to add to be 180. So it makes sense when we plug it in, we get 50 plus 37 is 87, and yes, they add to 180. Plug it in for angle T. 125 minus 10 is 115. And the angle across from it has to add to be 180 with 115. So that is 65. The measure of angle V, 65 degrees. So we can use a compass and a straight edge to construct a square in a circle. So inscribed square. Square inscribed in a circle. So it's actually a really easy construction. You start with making a circle. So just take your compass, make it however large you would like it to be, but the one thing you need to make sure you have is draw the center on your paper first, so that way you can find it later. Otherwise, it's really difficult to find that center. So put a point on your paper, then move the point of your compass there, stretch it out as far as you want, and draw a circle. We're going to draw a diameter using straight edge. So we had to know that center so that we can draw the diameter that goes through, whoops, I missed it. It goes through that center. Alternatively, you could actually just start over, and I'll show you another way you could do that if you don't like those steps. You just draw a line first, and then put your compass anywhere on there and draw a circle. The line will be a little bit bigger than the circle, but that's okay. It's not going to mess it up. So essentially, you're making a pokeball right now. That's what it looks like. That's the start of your construction. So now all you have to do is from this, says A, B, so I'm going to label these A and B just so we can talk about them. You don't have to label them, but it's hard to know what we're talking about unless they are labeled. So you put your compass on A, and all we're doing is we're going to make the perpendicular bisector here. So if you remember, perpendicular bisector, put it on one endpoint, stretch it more than halfway, draw a semicircle, and do the exact same semicircle from the other point. What that does is creates another diameter of the circle. My line doesn't want to go where it's supposed to go. Creates another diameter of the circle. And these two diameters are the diagonals of the square. So really our construction's done. We just have to label these C and D to match up with what it's talking about in the directions. These 4 points that we labeled on the circle will be the 4 points of our square. So just draw the diagonals or the straight lines. Use your straight edge to connect the dots, and you made a square. There's your square.